Welcome everyone to our second video of the ABPDU VideoSOP series. Today I'm going to talk about our FeedPulse LabVIEW application. This is another software that we use to control pumps on our Sartorius Biostat-B bioreactor system. But unlike in the first video where I talked about a software that would support time-based feed profiles, in this video I'm going to talk about a software that can deliver defined amount of substrate on demand. So what does on demand mean? On demand means that we are only supplying substrate if the culture calls for it, if the culture runs out of substrate. In many cases the substrate is a carbon source like glucose. And now the question is, how do we know, or how does the feed pump or the feed algorithm know that the culture ran out of glucose? In many cases, you can utilize the dissolved oxygen signal, or in short DO. And you can use this signal as an indicator for substrate depletion. In aerobic fermentations, the dissolved oxygen probe is used to measure the concentration of oxygen in the liquid media. In the presence of a carbon source, the oxygen demand is relatively high. As a result, the DO probe will read values below 100%. However, once the cells run out of the carbon source, the demand for oxygen will stall, and the DO probe will register a sharp increase in dissolved oxygen. Depending on the metabolic activity of the culture, the rise in DO occurs within seconds. And it is this increase that we can use to trigger our feed pump. So how does this work? LabVIEW is constantly registering DO values, and it is evaluating a certain condition, which is the current dissolved oxygen value minus the minimum dissolved oxygen value greater than a certain threshold. Thereby, it is important to understand that the minimum DO value gets redefined after every feed bolus addition. The result is a dynamic reference value, also known as a floating baseline. Now, if the condition is true, LabVIEW will send a command to the feed pump to administer a feed bolus. With a known concentration of feed solution, you will be able to accurately calculate the amount of carbon source that went into the culture. If the condition is false, however, nothing will happen, and LabVIEW will keep evaluating until the next carbon depletion event occurs. On the bottom, you can see a dissolved oxygen time course with 3 substrate depletion events. Upon substrate depletion, feed is triggered, and with excess glucose available, the cells resume their metabolic activity and the dissolved oxygen signal comes back down again. The advantage of using dissolved oxygen signal-based feeding strategies is you don't have to know the glucose consumption rate of your organism. The culture will manage its glucose delivery independently, which will reduce the risk of over or underfeeding. This is particularly important if you're working with organisms that are sensitive towards excess carbon concentrations, like Crabtree positive yeast or E. coli. If you're interested in using our software, you can download it for free on abpdu.lbl.gov. When it comes to setting up the software, the first thing we want to do is to pull up the LabVIEW front panel. There we go, the FeedPulse VI. Similar to the first software, this is a 2-pager. One is the setup page and the other one is the operation page. On the setup page, you want to provide the location of a dynamic link library file, or DLL. The file is used to establish communication between LabVIEW and the Sartorius control tower, and it can be found in the Sartorius directory. The name of the file is mfcs ABPDU.dll. In order to make sure that the configuration file gets loaded correctly, we have to stop and restart the LabVIEW application at a later point in time. Next, you want to select the bioreactor that you want to work with. As you can see, we have 4 identical panels, and these correspond to our 4 bioreactors that we have here at the ABPDU. You want to make up your mind about the feeding parameters, which is the DO threshold in %, the pulse duration in milliseconds, and the pump speed in %. Now we want to set up the feed for the second bioreactor. For that, we select 20% pump speed, which based on a previous pump calibration corresponds to 2 milliliter of feed solution per minute. The pulse duration is set to 60,000 milliseconds or 60 seconds. The DO threshold is 20%. Now we want to click Channel Enable, start the VI, and move to the operation page and hit Feed Control Enable. As you can see, the current DO is 14%, and the minimum DO value that the system has seen so far is also 14%. As a result, the feed condition is false because the current DO is not 20% higher than the minimum value. However, if I change the DO threshold to 0, which of course doesn't make sense in a real experiment, with the new threshold value, LabVIEW evaluates the feed trigger condition as true in the current situation, and a 2 milliliter bolus will be added by activating the feed pump for 1 minute at 20% pump output. Once the 1 minute timer is up, LabVIEW will re-evaluate the feed trigger condition, and the next iteration of feeding may begin. If you are unsure how to design your feeding regime in your own experiment, try to aim for 5 grams per liter substrate bolus delivered in a 10-minute pump interval. This will keep your cells happy for a while, and it gives you enough time to evaluate the situation and to make changes to the LabVIEW parameters as needed.